Welcome back, folks. This is where it gets really interesting, the second half of the paper. So, a ratio problem like this, many different ways you could do it. A lot of people like to assign a certain number to it. We've got 2 to 3 and 9 to 1, where you've got 5 parts altogether there and 10 there, so a number like 100 can work well, but you don't have to. In fact, I prefer to, the key here is Olivia and Jessica have in total half as many as Fran and Gary have in total. So we know Fran and Gary have got the most. I'm just going to start off by thinking, right, 2 to 3. Fran, she's got her 2 parts there. To Gary, he's got 3. So if we just draw 5 boxes about the same size like that, then Olivia and Jessica are going to share half the amount. So I'm just going to put another bar in that goes along to exactly sort of halfway. And then I'm thinking, right, I know that there's 10 parts all together here. And we've got 1, 2, well, if we were to double that up, that would be 5, wouldn't it, like that? So if I was to drop that down there, and then split those in 2, I've got fifths again. And then if I was to do that again, I've got 10 parts altogether. They're saying Jessica has got Z suite, so Jessica is just the 1 to Olivia's 9, isn't it? So Jessica, I'm just going to give her a single Z in there. And I'm just going to write down, right, Jessica equals Z. So if that's true, Olivia, we know, has got 9 of those in there, hasn't she? 1, 2, 3, 4, 5, 6, 7, 8, 9. So she's got 9. How about Fran? Well, Fran was exactly that bit, wasn't it? Fran has got 4 for each fifth, hasn't she? So she's got 4 times 2, making 8. And Gary's then got 4, 8, 12 altogether. And we've kind of done it. Well, I mean, I was sort of saying Z's, but it doesn't really matter. It's just little boxes. Jessica's got 1 little box. Olivia's got 9. Fran's got 8. Gary's got 12. The only thing we've got to do now is make sure we put it in the order they're talking about. They're saying Fran is W, to Gary is X, to Olivia is Y, to Jess is Z. So all we need to do is go, right, who's Fran is 8, Gary is 12, Olivia is 9, and Jess is 1, and that's it. Now, I'm not sure we've actually done this in class, but it's not actually that tricky, folks. The graph is giving the volume of water in litres in a container at time t seconds after the water started to flow out of the container. So the speed at which it's going is dropping off over time. So it starts at a faster rate, and as there's less pressure, as it gets lower, it's going to be coming up less. So using the graph, work out an estimate for the rate at which water is flowing out of the container when t equals 12. So that's 12 seconds at 11:12. It's right there. What they're looking for us to do is say, right, how steep is that? Because it's really steep here, isn't it? And then as we're going along, it's getting gradually less steep. So what you've got to do is you've got to get a ruler and put a straight line which is, as near as you can make it, the same steepness as the curve is at that moment. Now I'm just going to draw a nice long straight line like that, and I then just need a right angled triangle. Gradient is going to tell us how steeply it's doing it. So it's gradient is the vertical divided by the horizontal, isn't it? And the rate at which it's doing is going to be litres per second. So per means divided by. So we're going to divide the litres by the time. And if I just look at, you can pick different places, but I put a thing across all the way across here, and that looks like 28 litres at that point up there, when time is 0, if it has all been doing it at that rate, and then it's got to 30. So I'm looking at 28 over 30, and 28 over 30, 28 divided by 30, 0.9333 recurring. That's what I've got there. But the important thing in terms of my working is that I've got my 28 litres divided by my 30 seconds, and then I'm going from there. So 0.93 recurring. So I'm then just going to pop on the line 0.93 litres per second. And as long as you have shown your numbers and you've got a straight line, they'll accept anything between 0.7 to 1.1. So I've done quite well because I'm pretty much halfway in between there. Right, so if these two lines have got, or the curve and the line have got one point in common, that means there'll be one place where your y value and x value could be the same. We've got to solve the simultaneous equations here, but it's not that difficult. We've got it in the form y equals here, so we just need to rearrange this equation here to make y the subject of the formula. We could do that by adding 5x and getting rid of positive 4, so taking 4. So y is going to equal 5x take 4. Now that I've got that, I could say that I can replace the y there with 5x minus 4 and say that 5x take 4 is equal to x squared plus 3x take 3. And now I've got a quadratic equation to solve. And weirdly, we're going to find out that we've just got one point that can work, hopefully. So we're going to take 5x from both sides and add 4, because for a quadratic you've got to make it equal 0. So x squared, 3 take 5 is negative 2x, negative 3 add 4 is plus 1. And then we just need to solve, factorise this, and if we factorise this we actually find that it would have to be x take 1 squared, or x take 1 times x take 1. You could write that as... So the only value which is going to work is if x equals 1. So if x equals 1, I should then really find out what y is, although it doesn't tell me exactly that I have to. So y is going to equal 5 take 4, which is 1. So the point 1, 1, and we've shown algebraically because we've solved it, showing all of our working, and we've given them the point that is the one point they have in common. Oh, and strictly speaking, to get the marks, we need to say something in words about that. So only one root x equals 1. They want to have something there to say that you have said that it's only 1, but it's an annoying way not to get a mark. Right, so direct proportion to the square, and y is directly proportional to the cube of z. So I've not seen one quite like this before, so let's just start off by doing what I would normally do, which is to say, if it's directly proportional to it, I know, to the square of it, I know it's going to be equal to a number, which we normally call k, times y squared. As far as y is concerned, that's always going to equal, well, we can't call it k because it's going to be something else, so let's call it m, times z cubed, because it's the cube of it. But I want to know x in terms of z, so how about if we put what we know in there instead? So what I mean by that is, instead of saying y, I can say that this will become k times mz cubed all squared, because that is y. Let's expand that bracket. It's going to give me x equals k, m times m is m squared, and z cubed squared would be z to the power 6. Now, I know all of this is going to make some number. I don't know what it is. And so I'm not really interested, to be honest, because I know that x is 32. So if we substitute in, then I could say that km squared is equal to 2 to the power 6. And 2 to the power 6 is 64. And doesn't really matter. Let's just let km squared equal, let's give it another letter, let's call it n. So 32 is equal to, put 2 to the power 6 in my calculator, I get 64. So to find out what n is, I just divide by 64 and get 32 over 64, which is a half, which is n. So all of that means that my final formula for x in terms of z would be that x is going to equal, instead of km squared, I'm putting my n, which is a half, times z to the power 6. Quite a strange one. You might need to watch that through a few times to make sense of it, but just give it a go, and hopefully we'll get one a bit nicer than that on the real thing. Right, so vectors are all about finding a route that works. So it's saying that D is on the point OB so that we have got a ratio of 2 to 3, so it's 2/5 of the way along there. E is on the point, so it's 1/5 along there, and we want to get from D to E. So first thing to do is we can get from O to B, and then we'll need to get that right fraction of that distance. So OB is equal to going up with the A and then going along with the B. So OD, we can therefore say, will be 2/5 of A plus B. Now, can I get from O to E in some way? Or how do I get from B to C? I can get from B to C all the way round the outside. So I would be talking about going to there, down to there, and then across to there. So B to C is going to be minus B, minus A, because we're going against the arrow, but then plus 3B. Well, we need to simplify that. 3 take 1 is 2, so it would be 2B take A. And going from B to E is going to be 1/5 of B to C. So B, E equals 1/5 of that. So how does that all help us? You're saying, well, if going from O to D is 2/5 of doing that, going from D to B must be the other 3/5. So I can say that DB is equal to 3/5 of A plus B. And then if I want to do D to E, D to E is going to equal DB plus BE. And I've got my DB and my BE, so DE is going to be the DB, which is that one, 3/5 of A plus B, plus 1/5 2B take A. Now that's going to be 3 marks out of 4 because we've done it all apart from it being in its simplest form. So now to get it in its simplest form, we're going to have to expand the brackets and simplify. So if I expand this bracket, I get 3/5 of A plus 3/5 of B. Expand this one, I'm going to get 2/5 of B minus 1/5 of A. So what's that giving me? 3/5 plus 2/5 is a whole B, and 3/5 take 1/5 is 2/5 of A. So it's 2/5 of A plus B. If that's really confused you, you might want to go away and have a look at some more vectors questions and start with some slightly simpler ones. But do take time to go back through it. It is all about just having a good look at the roots and just starting up with how could I get there? Any route that you like at all, just think it through, and then these ratios you need to break into fractions of how far you want to go. So you find an easy distance and then you need a fraction of that. Right, so what is all this saying? This is saying from one year to the next, the population of the number of animals is either increasing or decreasing. It must be decreasing because we're going from 4,000 down to 3,600, but it's being multiplied by the same number. So to get 2018, you would have to do 4,000 times k. And then to get from 2018 to 2019, whatever that was, would be multiplied by k again. So that means 4,000 times k squared would give you 3,610. So all I'm going to do is divide by 4,000 to say k squared is 3,610 over 4,000. And then I want what k is, not k squared, so then I'm going to do the square root of it. So that is what I'm going to put in the calculator. So start by hitting the square root button, then the fraction button inside it. 3610 over 4,000 is equal to 19/20. S to D it gives me 0.95. So that is the value of the constant k. Now I've got to admit, this one is a bit of a strange one, and I don't want to do your heads in and make you think for too long about it. I want you to think, just have a little bit of a go at something like this. The thing to think first of all is that if you threw it one time, there would be no chance, would there, of getting at least one head and at least one tail. But all probability adds up to 1. And if you think about getting a head at least one time, the more times you throw it, the more likely it is it's going to happen. But it's also happening for the tails at the same time. Now you're probably looking at that and thinking, what? But I don't want you to worry too much about that one. I think it's a niche question. I think it's very badly worded, and it's only 2 marks, and you can still get your grade 9 without getting too worried about it. But as long as you, if you had, out of 2 marks, if you had written down just 1 over 2 to the power n anywhere, you get 1 mark for that. So hopefully you might have done that. Great, so a bit of 3D trig to sort us out. So we want the size of the angle between AH. So first thing to do is draw in the line AH and the plane EFGH. Well, the easiest way to see that would be to draw a line along there to get your angle of elevation up like that. So I'm going to put a little X down there to show that we've identified which one it is that we want. Now I know that that length there is 6, and a big part of doing this, I think, is you're looking at 2D shapes within 3D shapes. So it's always a good idea just to work out the bits that you can, maybe drawing a little right angled triangles and stuff out to one side. So we could do with, you could do this one here, that length there, or we could do this. We need to know that is a right angle. So we need to, so we've got 6 centimeters. We've got our x being there. We've got our right angle. If I call that y, we could work that out using Pythagoras, because that distance there is 5. So I'm going to sketch that triangle as well. That's 5 centimeters for the width of the box, 9 centimeters for the length, and then you've got the hypotenuse there, haven't you? So it's going to be the square root of 9 squared plus 5 squared for the hypotenuse. So root 81 plus 25 is root 106. I'm not going to bother writing down what that will be with decimal points yet. I'm just going to put that over here as root 106. That is my y. And then I'm thinking just SOHCAHTOA. So what have I got? I've got the adjacent and I've got the opposite. And I've got nothing to do with the hypotenuse. So that means we're looking at TOA. And so TOA, let's write out what TOA means. Tan of the angle is equal to the opposite over the adjacent. So let's write that out with the stuff we've got. Tan x is equal to the opposite, which is 6 over the square root of 106. But we don't want tan x, we want what the angle is. So we need to divide both sides by tan. If you've forgotten what that means, if you look at your calculator, just above the tan it says tan to the minus 1. So if you get confused, have a look at your calculator, it might jog your mind on something. 6 over root 106, like that. And that's what we put into the calculator, that's all your working that you would need to have shown. In fact, if you've got that, you'll have all the marks apart from 1. So I've got tan negative 1, then hit me fraction button, 6 over root 106, come out of the fraction by double hitting that there and hitting the bracket, and then that's giving us 30.23. Now I've written down 4 significant figures because I noticed that they were asking me for 3, so then that's going to be 30.2 degrees. And that is something that's worth revising and going over and over if you didn't understand it. Right, now we did do some of this sort of thing in class. We did a whole load of different ones, but amazingly they've managed to come up with something a little bit more complex than what we'd been looking at. So this here is, as quite a few of them were, a difference between 2 squares. But what makes it more tricky is that this is like a compound square number. What I mean by that is 9 is a square and so is x squared. So I'm going to keep that 6x cubed on the top there, and that is going to, I could have 3x, and then this is what's going to plus and minus. Square root of 144 is 12, so 3x plus 12, 3x take 12 is a factorisation of that. That would expand to make that, because that's a square number, that's a square number, and that's a square number. Then we're going to be dividing. Well, we know when we divide, we keep, change, flip. So we've got the 3x minus 4 on the top and 2x to the power 4 on the bottom. Right, now, what can we divide by? I can certainly divide the 2 into the 6 3 times. I can divide x cubed into 4, or just leave me with an x on the bottom, and that's giving me 9, and what I need to have a little bit of a think, so we've got to get it towards that, haven't we? And what I'm noticing here, I've never seen one do this quite before. What I'm noticing here is that 3 goes into 3 and 4, there's 3 4s in there, so I'm going to be able to rewrite this. So let's do 3 yeah, I'm going to write it as 3 times an x minus 4. Just leave it like that on the top. And then this bracket here could be factorised as, you could take a factor of 3 out of it and have have x plus 4 inside, and you could have, and we're timesing that all by 3 and x take 4. Now what that means we can do is we can cancel the x minus 4 with the x minus 4, the 3 with the 3, the 3 with the 3, which means, of course, because we've divided both by 3, there is actually a hidden 1 times 1 times 1 on the top, which gives us 1. And on the bottom, we have got, we've got x and x plus 4. Does that work? Can I really do it like that? Oh yes, of course I can, because I missed this little x here, didn't I? That was x to the power 1. So I should have had that being times by x at the end. So that's where my x is outside of the bracket. That's what I was losing. And I've still got that bracket there of the x plus 4. Sorry about that messy bit there. Anyway, that's what we should end up with. And so we come to the last question on the paper, and it is solving simultaneous equations. And we've got a quadratic on the top. Actually, it's a kind of circle on the top. What we're going to need to do is substitute in for x or y. It's going to be x, is going to be easier. If I want to find out what make x the subject of this formula by taking 2y and adding 1 would give me x equals minus 2y plus 1. And then I'm going to substitute that for x into here. So where it says x, I'm going to write minus 2y plus 1 squared. Take 9y, take minus 2y plus 1 equals 2y squared take 12. Now I'm going to need to be careful when I expand these. Let's do this little double bracket first. Negative 2y, 1, negative 2y, and 1. Negative times negative is positive, so 2 2's are 4, y squared. Take 2y, and plus 1. So that's giving me 4y squared, take, peanut those together, 4y plus 1, take 9y, and then it's like there's a hidden 1 there. I think very often it's a good idea. You can think of it as, right, I'm going to take negative 2y and I'm going to take 1. Or you could think, there's a hidden 1 there, I'm going to expand the bracket. Negative times a negative is positive, negative times a positive is negative. So it gives me plus 2y take 1 is equal to 2y squared take 12. Now let's not try and do too much at once. Let's simplify the left hand side, and that's giving me 4y squared take 13 plus 2 is negative 11y. The 1 and the negative 1 cancel out, and then we've got 2y squared minus 12 on this side. Now we do need to make sure we have everything on one side to solve a quadratic, don't we? So if we take 2y squared and add 12 to both sides, we get 6y squared. Take 11y plus 12 equals 0. And rather annoyingly, we can't divide everything by 2 because that's an odd number. So we are going to need to work with that. 6 12s are 72. So we're looking for the pair of numbers whose product is 72 and who add to make negative 11. So we're looking at two negatives. So we're looking for two numbers that add to 11 but multiply to 72. That won't work. I must have done something wrong. Oh yes! taking 2y squared, not adding it. Sorry, so that is 2y squared. Now, if you want to at this point, of course, you can use the quadratic formula, and that's absolutely fine. In fact, shall we do that? Because it's always good practice. You've got the quadratic formula there, haven't you, on the formula sheet. So it is x is equal to, or we're doing y in this case, but is equal to negative b plus or minus b squared take 4ac all over 2a. That's going to be easier, isn't it? So our b is negative 11, so y is going to equal 11 plus or minus negative 11 squared. I'll just call that 11 squared because it'll be the same thing. Take 4 times a is 2 times c is 12 all over 2 times 2. And actually, I'm not going to worry about it. I'm just going to whack it all into the calculator like that. So I get 11 plus square root 11 squared, take open brackets 4 times 2 times 12, go to the bottom, 2 times 2, I reckon I can do that in one go, that'll be 4, press equals, and that gives me 4, and the other solution will be when it's a negative. So y equals 4, y equals, so all I have to do is go back into the fraction using the cursor keys, delete the plus, put the negative in, and that gives me 3 over 2. Now I haven't got everything yet because I also need to work out what x is, but I can do that using the linear equation. So remembering that x, in fact we had it as a, we'd rearranged it to that, hadn't we, equals negative 2y plus 1. So when y equals 4, x equals negative 2 times 4 is negative 8 plus 1 is negative 7, and when y equals 3 over 2, x is going to equal negative 2 times it, 2 times 3 is 6, negative 6 over 2 plus 1, well that will be negative 3 plus 1 is negative 2, and you can always put that in the calculator if you don't want to hurt your brain at that stage of the exam. We've been through a lot now, haven't we? So our final solutions are x equals negative 2, y equals 3 over 2, and x equals negative 7, y equals 4. And that is all, folks. I hope that you got on okay with that. Keep going through it. Don't worry if it didn't come out too well yet. We've still got plenty of time to revise, and just keep going, keep having a go at everything, and then looking to make the best of your, learn from your mistakes, get yourself another colour and fill in any working that you missed, and then give it another go later. The more you practice these same questions, go over them, it will help, believe me. Okay, cheerio everyone, bye bye.